All right, let's just take this last opportunity to really drive home some of these points. So this is my x-axis, this is my y-axis. And so I've basically given 2 points here, one in the red and one in the orange. And I'm just going to go ahead and show you the relevance of the unit circle by finding the polar form of these points from the rectangular coordinates that we've been given. Okay, so we'll call this one point 1. We'll call this one point 2. And so point 1 is basically at x 0.866 and a y value of 0.5. I hope everybody agrees with that. Point 2 I'll do over here is basically at an x value of negative 0.5 and a y value of 0.866. You might wonder why I picked 0.866. You'll see why later. And so I know from the slides earlier that I can go ahead and basically using trig, I have a right triangle right here. And I know that I can find the radius here, right? Or the magnitude of my vector, if you wish, by saying r is equal to the square root of x squared plus y squared, which in this case is 0.5 squared, 0.866 squared. Okay, so that is going to come out. Let's go ahead and throw it in the calculator. I already know what it's going to come out to, but I'm going to put it in the calculator anyways. So let's throw it in there. Squared, and I get 0.9999 because I rounded, but really what it's ultimately going to be is 1, which is exactly what we should expect because I picked a point that was on the unit circle. Okay, of course I didn't specify the size of this circle to start. I just specified the x and y coordinates, but it turns out that the radius is in fact 1. Now what if I wanted to know this angle phi? I can go ahead and say phi is equal to the tan inverse of my y coordinate, which is going to be 0.5, divided by my x coordinate, which is 0.866. So let's go ahead and throw that in the calculator. 0.5 divided by 0.866, and I get 30.0007, which is equivalent to roughly 30 degrees. Okay, my calculator is in degrees. And so the reason why I picked 0.866 is because that is equal to root 3 over 2. And so I could have written my my points x, y coordinates in fraction rather than in decimal, which would have been root 3 over 2 in the x direction and 1/2 in the y direction. And so if I come over to 30 degrees on my unit circle, I should see root 3 over 2 1/2 as the coordinate. So let's go back. 30 degrees, root 3 over 2, 1/2. Boom. Okay, so we just kind of proved how these numbers are derived. Actually, how these numbers are derived from these numbers. Could always go the other way. If I had given you 30 degrees and I had given you the length of 1, you could have easily used the other equations to convert to Cartesian and determine these values, okay? Let's real quickly do the same for the orange point, but I'm not going to really explain it so much since it's pretty straightforward now. Let's go r, which is going to be 0.5 negative squared. Doesn't matter that it's negative, it's going to get squared. 0.86 squared. You can see that this is actually the exact same expression as this expression, except this one's negative, but the negative goes away. So of course I would get that r is 1, and that's exactly what I would expect because we are again picking a point on the unit circle. So my r is going to be 1. And now the question is, what is this angle? Let's take a look. It's going to be the tan inverse of my y value, which is 0.866, divided by my x value, which is negative 0.5. Let me throw this in my calculator, and I get 0.866 divided by negative 0.5. I get negative 60 degrees. What did I do wrong here? Tan inverse of 0.866 divided by negative 0.5. Negative 60 degrees. Interesting. All right, I'm going to have to explore this. I can't determine straight off the bat. The only thing that I can say that is 60 degrees is this, but I don't know why it would be calculating my angle from the negative x-axis, because that's definitely not what it's supposed to be calculating. Maybe I put the values in wrong, because negative 60 degrees would be down here, and that would be kind of here. Maybe I wrote something incorrectly. Tan inverse of y over x. Interesting. Let me go ahead and end this video.